Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Anna Natasha with metric number of 20251527225. Today I will be presenting about my iterative algorithm analysis for CSC645. So I have implemented a linear search algorithm within a weapon database application. This program allows users to quickly verify if a specific weapon power exists in the system, which is the one stored in array. So the core of this program is a standard iterative search. It uses a while loop for the user interface and a for loop to traverse in the weapon power array. So for the input and output, the input is an integer representing the weapon power for search that will be searched in the array. So the output is either the specific slot index where the weapon was found or a message stating that it is not found in the database, which means the weapon power doesn't exist. So the reliability, the code handles user termination with a sentinel value of 0 and includes logic to prevent redundant processing once a match is found. So next is the analytical steps and debug.
First, let's look at the initialization of the program. At the top, we see constant time operation. Things like initializing the weapon power array, setting up a scanner for input, and also printing the output. This can be marked as 1 or O1, which is a constant. Will be combined, becoming O4. Then, we enter loop 1, a while loop controlled by the variable keep playing. This loop allows the user to perform multiple searches. Within this loop, there is a small display loops that iterates through the weapon array to show the available power to the user. We also see the input section where the program waits for the user to enter a target weapon. Next, moving on to the part 2, the linear search algorithm. Now, let's focus to the core logic, the search. If the user doesn't choose to exit, the program enters an else block to perform a linear search, labeled here as loop 2. The basic operation being analyzed is the comparison where the program checks if the current item in the array matches the target. Inside this loop, we have 4 distinct steps: printing, updating, and also breaking the loop. To turn this into a match, we use the summation. Since the loop goes from index 0 to n-1, we write it as sum n-1, I equal to 0 times 1, using the formula u minus 1 plus 1, where u is the upper bound and 1 is the lower bound. We calculate n minus 1 minus 0 plus 1, which simplifies to n, which means the search loop complexity is directly tied to the number of items in the database. Moving on to part 3, final mathematical derivation. Finally, we bring everything together into one complete formula to find the overall complexity of the system. We start with an auto summation, sum mj equal 1, where m represents the number of times the user chooses to run the search. Inside the bracket, we add up all the operations. The display loop, summation n minus 1, I equal to 0 times 1, constant operation like overhead and UI messages, plus 7 and plus 1.
The search loop itself, which is represented as sum n minus 1, x equal to 0, 1 times 4 plus 2, to account for the internal operation and the not found check. When we simplify this algebra, we get m bracket n plus 8 plus bracket 4n plus 2 bracket close bracket close bracket. This combines to become m bracket 5n plus 10. Factoring out the 5 gives us the final formula, 5m n plus 2. Because most significant factor relative to the size of the database is n, we conclude that linear search has a time complexity of O(n).
That's all from me. Thank you.